Hey everybody, it's Gil here with the Sailing Vessel Dream Chaser, and I got my assistant Swabby here with me. If you've watched our videos, you know that anytime I'm about to do a major project or something with the boat on a topic that I'm not 100% confident I understand, I go out and I do research. And oftentimes, if you've done it, you've run into the same situation. You go out to the interwebs and you ask the question in forums, you read blogs, you read information from manufacturers, and you walk away less clear than you were before you even started. It's the same exact thing when it comes to solar panels. So we are considering how we're going to build our solar array on Dream Chaser. And if you have a sailboat, you know most people put their solar panels across the dinghy davits, or they put it across their bimini, or they lay them on the deck or the coach house in some way. We're no different. But the reality of doing that is there is going to be a time when your boom is off to one side and potentially causing a shadow line on a portion of one or multiple solar panels. The way you wire solar panels in is very specific around what your output is going to be. And I've read a lot of different theories on wiring in parallel versus wiring in series, and I want to do a complete test. So here's what we're going to do today. We're going to set up a mini solar system to do some testing, and I want to validate a few things. I want to take one solar panel and measure my output, measure my amperage. I then want to hook it into a solar charge controller and up to the battery, along with a battery monitoring system, so I can see just how much amperage is coming in off of that solar panel from one solar panel. I'm then going to take probably just a broom handle or something to mimic what it would look like if the boom or some rigging caused a shadow to go across that panel. And I want to see just what I reduce to from a percentage perspective and total amperage. That'll be my single solar panel test. Then the next test is going to be what would happen if I wired two solar panels, right? So two panels together in parallel into a single charge controller. And then I mimicked shadow going across one of those. I'm going to test that. I'm going to validate all of my reduction in amperage as well. You staring at me, kiddo?
Yeah.
I can tell. Then we're going to do another test, and that's going to be to take one solar panel connected to a charge controller and another solar panel connected to the charge controller, and then the two charge controllers coming out and going to the battery. And they'll go through the battery monitoring system at that point in time. And then we're going to measure that same exact scenario of the boom, mimic the boom going casting a shadow over one of the panels. My suspicion is that when wired to separate charge controllers, I will get a larger volume of output from the solar panels themselves. But with this test, we are going to get some true specific details on exactly what the degradation is from a shadow line, and specifically what that same exact shadow line does when wired in parallel versus wired in series or separate charge controllers. So in order to do this test, we didn't want to spend the money we would spend on the really high quality solar panels that we intend to put on the boat. And I didn't mind spending $100, $150 for some very inexpensive materials to run this test. And frankly, it's kind of a dry run on letting me test all of this out. The great news is this won't go to waste. I can reuse these components for anything from underwater dock lights to charging a portable solar system on our camper. So the good news is they won't go to waste. But here's what we went ahead and purchased. I purchased two 25-watt small solar panels. And again, these are small because I'm doing a scaled-down approach. I also bought two charge controllers, and these are small little imports from China. My gosh, I think these things were like $13 a piece. These happen to be Pwm controllers. I won't go into a ton of detail about that, but when I install them on the boat, they will absolutely be Mppt controllers. Mppt is a smarter, logical charge controller that lets you milk a little bit more juice out of the solar panels over the course of a day, especially with varied degrees of sunlight. So for this test, though, I'm using the cheapy stuff. But my test will be consistent. It'll be consistent with one panel, consistent with parallel and two, and consistent with serial of two. And as you can see, I bought two of these controllers, so identical on both sides. Each of these, by the way, are rated at 30 amps. They have a max input of 380 watts, so more than sufficient for my whopping 25-watt panel. I also bought some Blue Sea 4-to-1 bus bars. And what this is going to do is allow my little bench test to be very easy to change configuration. The last thing I picked up for this test was an inexpensive battery monitoring system. If you have a boat or even an RV, you likely have a battery monitoring system. A bunch of companies make them, Xantrex and others, and they range anywhere from $200 on up to $600 depending on the sophistication level of the one you get. This is a little $20, $25 jobber from China. It'll be more than sufficient for this particular job. What this does is it sits right, there's a shunt that sits between the negative cables that come off of the batteries and all of the negative connections that go to the rest of the loads, essentially to the rest of the distribution box. And that shunt measures all of the different voltages coming in and going out. So it measures all of those. And the battery monitoring system will give you, think of it like a fuel gauge for your battery. So it'll show you how full they are from a percentage perspective. It will also show you your total watts in, your total amps in, and if you have loads on, it'll show you your total loads out in wattage and or amps. So for our test today, we are really going to be just doing input voltage because we're going to be testing the charging capacity of solar panels. I will have zero load going out, at least for this particular test. So with these little products here, plus our 2 identical solar panels, we'll be able to set up our testing scenario and take you through every piece and step of this. I'll show you how we wire them, and then I'll show you the results of every one of those. And I'll summarize it at the end with what the recommendation would be based on a potential for getting shading across part of your solar panels. And if you have a boat, you're likely going to have shading, whether it's from the rigging, the boom, the sails, something, the mast, something's likely going to be shading part of one of those solar panels. So with that, I'm going to go ahead and unbox each of these, show you the different products I have. For anyone interested in a test like this or setting something up for, solar lights in your garden or, maybe a tiny little solar charge controller to leave on your power boat in your storage location just to keep your batteries topped up, I'll be happy to put links down below for all of these products that I'm using. As I mentioned before, these are really inexpensive ones. They are not ones that I would put for cruise ready on the sailboat, but they're more than sufficient for this testing and for applications that maybe wouldn't be so far away from land and support. If I'm putting something like this at my house and I spend 12 bucks on a solar charge controller and it dies in a year, it's not a big deal to buy another one and pop it back in. That's a big deal if you're on your sailboat and you're halfway across the Gulf of Mexico relying on that power. So for anybody interested, I will put links to all of these smaller, less expensive parts that I'm using in my test down in the description below. Eventually we'll do another very similar video where we actually put all of the real stuff with the good quality product on the boat, and I'll do a video on that and also show you why we chose the panels we did. And again, as I mentioned, I always do tests because I need to understand the real output. I can't just trust what other people say. I need to see it for myself in a way that lets me understand what's best for me. And this video is going to be all about how I get the data and the decision that I make for us. All right, we'll start with the solar charge controllers here. I'm just going to take one of these out of the box and kind of show you what this looks like. So as you can see, this is a really small unit, and this one happens to be a Pwm Charger, like I said before, as opposed to Mppt. Pretty simple. We have solar panel in, connect to the battery, and then this is where your load would go out if we were running a light or something like that. This one also has 2 USB chargers on it, so you could charge a cell phone or something like that. This unit is a 30 amp unit, and the max input on this is 390 watts, or about 32 amps, which is good because we have 25 amp solar panels. So this is going to be perfect for our test that we have. I also have 2 of these Blue Sea bus bars, and I bought the ones with the covers on them. Now these are kind of nice. You put your larger lugs right here on the sides, and then you have screws with lock washers that you can connect any of your loads into. So one of these will be for positive, and the other will be for negative. And then the last thing we have here is our battery monitoring system. And just to give you an idea on this thing, pretty simple, as I mentioned before. It comes with its very small controller, the actual display. You can see it's really, really small, nothing large here at all. It also comes with a shunt, and it comes with the wires that connect to that particular shunt. So that's it. That's all we get out of this, which again, more than enough for our tests. And then the last thing I'll show you is the solar panels themselves. Again, 25-watt solar panels. So I've saved you the boredom of actually watching me set all of this up. Let me kind of orient you with what I have. So I have 2 panels right here. And again, I mentioned how I'm going to test these, but I'm getting everything set up for the test. 2 panels, and each panel is going to be wired into one of the solar charge controllers. And I'll talk about exactly how each of those are wired through each test. The solar charge controller, one at a time, will go from the controller out to the shunt, and I've got a very small monitor right here. So and just so I could test some load as well, I just went ahead and put a small dimmer switch here, and then I wired up 3 little navigation lights, red, green, and a stern light, just so I can turn those on and off if I want to see what a load looks like on this. Well, good morning, everybody. I had to wait till the next day. Yesterday, I started my test right as some cloud cover came by, so it's really good today. I've got a couple little tiny sparse clouds out there, but I'm definitely exposed into full sun, so I'll have a good, consistent test across everything we want to do this morning. So, yeah, let's go ahead and get started. As I mentioned, we're going to do our first test with a single panel and a single controller, and we're going to track down what the amps and watts are. Because these are only 25 watt panels, it may be easier to do this in watts because the amps are going to be a portion of an amp in most cases. So I'll probably call about both numbers, and I'll show you a grid and all the results at the end of the video. But I'm going to track amps and watts in, and then I'm going to go ahead and shade 5% of the panel, much like you would see if, for example, the boom moved over the edge of the solar panel on a boat. So I'll track what that is, amps and watts with about 5% of the panel blocked. I'm just going to use this little old light panel. It's, I don't know, maybe 3 inches across, maybe 3.5. It looks like it's just slightly narrower than a 2x4. So I'll use that to mimic the shade from the boom. And then I'm going to do a third test. I decided to do this last night while I was laying in bed. I decided to also do a test with about 20% of the panel blocked from the sun. So think about that as if you have the sail up and it's blocking a portion of it. Just want to see what the difference is in output if it's 5% blocked versus 20%. So let's get our first test. First thing we're going to do is we're going to hook up the far solar panel, so just a single panel going into one controller. You can see this one right here is not connected to anything at all. We'll just leave that disconnected, and we'll go ahead and plug this panel in, and we'll see what we get here. All right, we're getting 0.6 amps or 7.95 watts. So we're now just going to shade one of these panels, and again, think of this as the boom kind of coming across the side of it. All right, we're putting out 6.3 watts or 507 amps. So 6.3, 507. And now we're going to do the same test, but we're going to block about 20% of the actual panel. So you can see I don't know if you can see that shade line there. And we're at 4.8 watts or 0.35 amps. Okay, so first test conducted, and we definitely saw what we would expect, a degradation in the output when you cover up 10% and then obviously, or 5% of the panel, and then when you cover up about 20%, certainly additional degradation. We finished the first test, and we're now starting on the second test. Remember, the second test is both of these are connected in parallel into a single solar charge controller. We've got 12.7 watts or 957 milliamps. So I'm going to redo these tests every 30 minutes for the next 2.5 hours. So I'll have 5 more tests of every one of these different scenarios. That will allow me to sort of eliminate any anomalies. And at the very end of this video, I will post the results of the averages of all of those, so you can kind of see what the true answer is here. And averages are what you really want when you're talking about being at anchor all day somewhere on the sailboat and really understanding what your output is. So I think that the result of this is there's really multiple tactics you could take. You could go crazy and put every single solar panel on its own controller, and I think you know, mathematically you would be eking out every possible watt of energy from the sun if you did that. But there's probably a cost-benefit analysis that needs to be done on that, and I don't know how valuable that would be. I think it all depends on what you're paying per controller. If you've got Victron controllers and you're paying $150 a controller and you have 9 panels, it's quite an investment up front for the small output difference you might get. But I think there's other ways that you can look at your layout of the boat and you can determine what's logical for you. Let's say you have a sloop rig boat, so single mast and boom. You might want to wire all of your port side panels to one controller and all of your starboard panels to another controller. That way, if you're on one tack or the other, theoretically you're only going to be shading that particular tack, that particular side. That could be one theory to do. And again, it depends on your layout. You know, we have a catch rig, so if we'd had some on the coach house and some on the dinghy davits, we might have to separate those depending on kind of how we see shade typically hit our boat. So before I install different different solar charge controllers, I would probably spend a little bit of time and really look at, when I'm sailing, where are my best locations with the least amount of shade, the least percent covered on the panels themselves. Keep in mind, I'm doing this on really cheap panels. Certainly when we buy them on the boat, we'll be buying some high output monocrystalline cells, and they'll react slightly different to what percent drop there is on each cell. I think all of them handle this just a little bit differently. So let's go ahead and familiarize ourselves with this particular graph, and this is the average values for all of the tests. And we'll start with the top 3 bars. This was one panel wired to one controller, and you can see that the blue bar was the full sun, the green was with a 5% shaded, mimicking a boom, and the gray bar was with 20% shaded. And clearly that's our lowest output of all of them. What's interesting is the next section down is when I had 2 panels wired into a single controller. And in that case, certainly the values were higher and you saw less degradation from the shading, from the 12.7 down to 11.8 and 11.7 respectively. But here's the part that I found most interesting. So the bottom 3 colored bars represent 2 panels hooked to 2 different controllers, so 1 panel to 1 controller each. And in this particular case, you'll notice not only was our output higher, from 12.7 watts up to the 13.8 watts that we saw with them wired in series, my degradation was a little bit less as well. So in this particular case, you can see that my 20% shaded is putting out almost the same exact wattage as having 2 panels wired to a single controller. So certainly you could eke out a little bit more power if you use this methodology, for sure. All right, I hope you enjoyed this video. I hope it was helpful for you. I think it's going to give you a good answer, sort of empirical data on exactly what we saw when we did this testing and separated it. This was a fun little project. It's a nice way to test out your theory and what you're doing in a very easy to get to location before you run all the wires down through pulpit lines and drill holes in the boat and everything else. So fun way to do this. Yeah, I'm excited. Thanks everybody. We'll see you next Friday. Bye now. Safe sailing.